Hi guys! Welcome back to my channel. So for today's video, I'm going to share with you the content and summary of what I've learned in CCNAv7 Module 11. So here at CCNAv7, we have Module 11, the Switch Security Configuration. What will I learn in this module? So the module title, Switch Security Configuration. The objective of this module is to configure switch security to mitigate LAN attacks. Topic title. The topic titles implement port security, mitigate VLAN attacks, mitigate DHCP attacks, mitigate ARP attacks, mitigate STP attacks, and these are the topic objectives. Next. Module 11.1 Implement port security. Implement port security to mitigate MAC address table attacks. So, port security. Port security basics are switch security feature that allows us to limit the number of MAC addresses learned on per port basis. It also can be configured to limit a port to specific MAC addresses. So all switch ports interfaces should be secure before the switch is deployed for production use. How a port is secured depends on its function. A simple method that many administrators use to help secure the network from unauthorized access is to disable all unused ports on a switch. So, for example, if a Catalyst 2960 switch has 24 ports and there are 3 fast Ethernet connections in use, it is good practice to disable the 21 unused ports and to navigate each unused port and issue the Cisco iOS Shutdown Command. If a port must be reactivated at all the time or a later time, it can be enabled with no shutdown command. So as you can see in this figure, a range of ports use the interface range command. Switch config sharp interface range, type the module, first number, and the last number. For example, to shut down ports for fast Ethernet 0/8 through fast Ethernet 0/24 on S1, you would enter the following command. So as you can see, S1 config interface range fast Ethernet 0/8 24 config if range shutdown. Link pipes. As you can see, everything is link pipe change. Everything is changed. Interface fast Ethernet 08. Change state to administratively down. Output omitted. Link pipe change. Interface fast Ethernet 0/24. Change state to administratively down. And yes. The simplest and most effective method to prevent MAC address table overflow attacks is to enable port security. So as you can see, I've already summarized the module 11 and I already typed it here in my PowerPoint presentation. So you can understand or listen, you can listen to my what I'm saying, and also you can directly watch what I'm talking about. So port security limits the number of valid MAC addresses allowed on a port. It allows an administrator to manually configure MAC addresses for a port or to permit the switch to dynamically learn a limited number of MAC addresses. When a port configured with port security receives a frame, the source MAC address of the frame is compared to the list of secure source MAC addresses that were manually configured or dynamically learned on the port. By limiting the number of permitted MAC addresses on a port to 1, port security can be used to control unauthorized access to the network, as shown in this figure. So, going back in chapter or module 11, enable port security. So, notice in the example here, the switch port security, this command was rejected. This is because port security can only be configured on manual configured access ports or manually configured trunk ports. By default, layer 2, switch ports are set to dynamic auto or trunking on. Therefore, in the example, the port is configured by the switch port mode access. As you can see here, switch port mode access, interface configuration command, switch port security, and so we call this as switch port security command. Next, show port security interface command. Use the show port security interface command to display the current port security settings for pass Ethernet 0/1 as shown in the example. Show port security interface pass Ethernet 0/1. Notice how port security is enabled. Port security is enabled. The violation mode is shutdown or shutdown. The violation mode is shutdown, and how the maximum number of MAC addresses is 1. If a device is connected to the port, the switch will automatically add the device's MAC address as a secure MAC. So in this example, no device is connected to the port. If an active port is configured with the switch port security command and more than one device is connected to that port, the port will transition to the error disabled state. This condition is discussed later in this topic. So after port security is enabled, other port security specifics can be configured as shown in the example. So, port security aging commands, MAC address, secure MAC address, maximum MAC secure addresses, violation, security violation mode. Switch port security. So, module 11.2, mitigate VLAN attacks. Explain how to configure DTP and native VLAN to mitigate VLAN attacks. As a quick review, a VLAN hopping attack can be launched in one of three ways. Spoofing DTP messages from the attacking host to cause the switch to enter trunking mode. From here, the attacker can send traffic tag with the target VLAN, and the switch then delivers the packets to the destination. Introducing a RUG switch and enabling trunking, the attacker can be access all the VLANs on the victim switch from the RUG switch. Another type of VLAN hopping attack is a double tagging or double encapsulated attack. This attack takes advantage of the way hardware on most switches operate. So these are the steps to mitigate VLAN hopping attacks. VLAN hopping can be mitigated by implementing the following configurations. Module 11.3, mitigate DHCP attacks. Explain how to configure DHCP snooping to mitigate DHCP attacks. Syntax checker, mitigate DHCP attacks. Implement DHCP snooping for a switch based on the following topology and specified requirements. So as you can see here, these are the commands. Next. This figure, the reference topology for this DHCP snooping example is shown in the figure. Notice that F05 or the fast Ethernet 05 is an untrusted port because it connects to a PC. F01 or fast Ethernet 01 is a trusted port because it connects to the DHCP server, as shown as the figure. Module 11.4 Mitigate ARP Attacks. Explain how to configure ARP inspection to mitigate ARP attacks. Dynamic ARP inspection. So in a typical ARP attack, a threat actor can send unsolicited ARP replies to other hosts on the subnet with the MAC address of the threat actor and the IP address of the default gateway. To prevent ARP spoofing and the resulting ARP poisoning, a switch must ensure that only valid ARP requests and replies are relayed. Syntax checker mitigate ARP attacks. So this is the picture. Implement DAI for a switch based on the following topology and specified requirements. A PC, a switch, a DHCP server, fast Ethernet 01, gigabit Ethernet 02 and 01, enabling DHCP snooping and DAI for VLANs 10, 20, 30, and negative 49. Module 11.5 Mitigate STP attacks. Explain how to configure port fast and BPDU guard to mitigate STP attacks. Recall that network attackers can manipulate the spanning tree protocol or STP to conduct an attack by spoofing the root bridge and changing the topology of a network. To mitigate spanning tree protocol or STP manipulation attacks, use port fast and bridge protocol data unit or BPDU guard. So Port fast immediately brings an interface configured as an access or trunk port to the forwarding state from a blocking state, bypassing the listening and learning states. Apply to all end-user ports. Port pass should only be configured on ports attached to end devices. And BPDU guard immediately error disables a port that receives a BPDU. Like port fast, BPDU guard should only be configured on interfaces attached to end devices. So in this figure, port fast and BPDU guard, the access ports for S1 or switch 1 should be configured with port fast, and BPDU guards. Configure port fast. Notice that when port fast is enabled, warning messages are displayed. So these are the warning messages because of the port fast is enabled. So configure port fast. Port fast bypasses the STP listening and learning states to minimize the time that access ports must wait for STP to converge. If port fast is enabled on a port connecting to another switch, there is a risk of creating a spanning tree loop. So this is all about port fast. Configure BPDU guard. Note that always enable BPDU guard on all port fast enabled ports. So just always remember this note. So even though port fast is enabled, the interface will still listen for BPDUs. Unexpected BPDUs might be accidental or part of an unauthorized attempt to add a switch to the network. If any BPDUs are on a BPDU guard enabled port, that port is put into error disabled state. This means that the port is shut down and must be manually re-enabled or automatically recovered through the Reducible Recovery Cost P-Secure Violation Global Command. So this is all about the BPDU guard to display information about the state of spanning tree. Use the show spanning tree summary command. In the example, port fast default and BPDU guard are both enabled as the default state for ports configured as access mode. Spanning tree summary. S1 sharp show spanning tree summary. Syntax checker mitigate STP attacks. So implement port fast and BPDU guard for a switch based on the following topology and specified requirements. The syntax checker mitigate STP attacks. So these are the commands that we need. So all of the commands here is enabled. But there's a lot there is some command that is also disabled. But for us to know that this is the correct command, always look at the bottom part. You will see that you have successfully configured and verified port fast and BPDU guard for the switch.